Hey there, this is the Rankine Cycle, presented by Alex Sullivan, Bradley Mills, and Joey Mazzola.
So, what is the Rankine cycle? The Rankine cycle is a thermodynamic process in which heat is converted into mechanical energy. Although the Rankine cycle isn't specific to nuclear power, it is a core concept that needs to be understood to fully grip how a nuclear power station generates electricity. The way this cycle works is with four major components: the heat source, in our example, a nuclear reactor, a steam turbine, a condenser, and a feed pump. Each component serves a specific purpose within the cycle. Starting off with the reactor, its job is to take the heat from radioactive fuel and transfer that heat to the system's water in order to produce steam. This steam is then sent to the steam turbine, where the turbine uses the pressure of the steam to spin a shaft. The shaft of the turbine is coupled with the shaft of a generator that converts the rotational energy of the shaft into electricity. After the steam is passed through the turbine, it is received by the condenser. The condenser's job is to lower the temperature of the steam and condense it back into water. The condenser uses an external source of cooling water that runs through its own tubes. The heat from the steam is then transferred to this external cooling water, lowering the temperature of the steam and condensing it into water. The last step of the cycle is for the water being recollected to be sent back into the reactor to be used again. This is accomplished using what we call a feed pump. The feed pump raises the pressure of the water in order for it to overcome the pressures within the reactor. Now that the water is back in the reactor, the cycle can continue.
This slide presents our initial hand-drawn sketches of the main components in our Rankine cycle model, including the turbine, condenser, and feed pump. Here we have SolidWorks drawings of some of our components. This slide showcases the testing phase of our project, where we conducted clearance tests to check for proper fit and spacing, and stress tests to assess the strength.
For this project, our team charter acted as a guideline that led us to success. We utilized clear lines of communication, individual adaptability, and a clear division of responsibilities. Now, enjoy a demonstration of how each of our sub-assemblies progress from prototypes to finished 3D models. And thank you for watching the Rankine Cycle.